morning, everybody, and thank you for coming. It's an exciting day. I would like to introduce Subhash D'Souza, Director of Big Data and Operations in Data Intelligence Group at Warner Brothers. He's the founder and organizer of this day, Big Data Day LA, which is going to be known as DataCon LA, and also organizes Los Angeles Big Data Users Group and the Los Angeles Apache Spark User Group. So let's welcome Subhash.
Thank you, Dipinder, and thank you everyone for attending today. So first, I want to apologize for the chaos that was outside. Yeah, we expected the printers to work. Unfortunately, they didn't. But Murphy's law, right? Something bad happens, always does. Must be prepared for it. But anyways, thank you once again for all of you coming. So few quick logistics. If you didn't get a badge, we're gonna take care of it. Probably just after this or a little bit after 10, we'll probably have all the badges available. Please come back to the registration desk and collect your badge. With that, I just want to make a few quick announcements, and one of the big announcements we're going to make is, I don't know if you guys have seen the email that went out yesterday, but actually, how many of you have seen the email? How many of you noticed the changes that we've done? Quick raise of hands. Okay, some number, okay. So how many of you heard that we have rebranded ourselves, the new name? If you haven't, that's a new name, DataCon LA. So there's a few quick reasons I want to just explain to you why we did this. When I first started this off back in 2013, we were in a much smaller room, with about 250 people. This year, it's 2018, we're expecting 1,800. So the growth has been phenomenal, and it's all thanks to you guys. So I want to, thank all of you, and just a round of applause to everyone out here. I really want to thank you. So back in 2013, when I started this, I initially thought, big data was the hype, the buzz. Everyone felt that there was going to be a lot of talk around it, and it was. You could see it in the atmosphere and the change that people are expecting, big data to be the next big thing. And for a long time, there was a lot of talk about it. But as time progressed, technology evolves. That's a very common thing. Things change, and you always want to keep with the times. So I felt, big data, even though we were still talking a lot of, big data technologies, I felt it became more imperative that we talk about not just big data, but data as a whole. And that includes, data science, AI, machine learning, and some of the new emerging technologies such as blockchain, AR, VR. And you can actually see it in the evolving technological landscape changes out there, that you will see a lot of these new technologies being talked about. So I felt, having a name that's more neutral kind of makes sense for us. So with that, we went with, DataCon LA. I hope you guys like the name. It's pretty self-explanatory, and it keeps us, ready for the future. We can evolve to more things as things change. So what do you guys think? Are you guys excited about the new name? Awesome. So we have a number of great things for you today. Obviously, we have the sessions. That's a typical thing with any conference, but a couple of new things we added this year, actually not new, but second year, the Startup Showcase. As you guys have seen, we have 6 finalists this year. We have a great number of prizes for them, and it's going to be really awesome. So if you guys can come down here between 2 and 4, we're going to do a great session on people pitching their companies, and you can see some new evolving technologies. One of the things we have kept with the theme, doing a theme every year, is that we also include a theme for this year. This year it's going to be media and entertainment. And if you see the Startup Showcase as well as the media panel, which is immediately after the Startup Showcase, and that's at 4 right here in Bovard, it's on media and entertainment. All of our startups that you can see today will be pitching their companies, and they're mainly focused on entertainment and how these companies can help the entertainment industry in some way or fashion. We are Hollywood, aren't we, right? We should be promoting them in some way or fashion. What do you guys think? Right? Yeah, exactly. Okay, so that's all I have from my side, but I do want to mention one thing. I just want to thank all of the volunteers and committee leaders. I don't know how many volunteers are out here in the room, but if you are here, can you just stand up and raise your hands? Anyone stand? Please stand up. Anyone, any of the volunteers out here? Just stand up. Just want to, please give a round of applause. So none of this would have been possible without these people out here. So I want to thank each one of them, a lot. I also want to thank all of the committee leaders, and who you are. I'm not going to mention your names, but I want to get the ball rolling. So with that, I would like to introduce my Next speaker, actually, Dipinder, you're going to introduce, yeah. So we're going to have Dipinder come and introduce the next speaker. But thanks again, and if you have a chance, come by and say hi. I may be busy, but you know, I can only say hi to you guys. Thank you very much.
Thanks, Subhash. Well, our next speaker is Dr. Abbas Sharif. So I'm pleased to introduce him. He's academic director, Master of Science in Business Analytics program at our host, the University of Southern California. Professor Sharif specializes in the field of statistical computing and data visualization. He has developed and published new multivariate visualization techniques for functional data. And currently, he is developing visualization techniques to study brain activity data. Professor Sharif teaches statistics courses that range from introductory statistics to advanced modern statistical learning techniques, statistical computing, and data visualization. So please welcome Dr. Abbas Sharif.
Thank you. Wow. Good morning, everyone. You know, there's nothing surprising to have all of this audience here, but what I'm really surprised is that we have all of this energy in a weekend at 8 a.m. in the morning. So thank you for making this happen. Thank you for coming to our campus. My name is Abbas Sharif, and I'm the academic director for the Business Analytics program here at USC. At USC, we wanted to make sure that we're reaching out to our community and giving back to the data community in Southern California, and in the United States. And believe it or not, we have also attendees from outside the United States. So welcome to our campus here in LA. For those of you who were not here last year, I'm going to give you a very brief introduction to our program. But instead of telling you what is business analytics, I'm going to tell you what makes us unique, what makes us different. Now, all of you, we know the field of data science, and you all work in companies. However, when you hire the new data scientists, you still see that sometimes they lack certain skills. And most of the skills that they lack, it's not about the computing skill, it's not about the machine learning skill. Most importantly, it's the business acumen or the business strategy skills. And that's what we offer in our program, in addition to the computer science, to the machine learning and statistics and optimization as well. So we want to make sure that you are all welcome here. I'm going to cut it brief so that we can make sure that the schedule goes on time. Thank you again, and I'll see you around. Make sure to come to our booth and get your badge stickers. If you love R, if you love Python, if you love NoSQL, whatever you like, all of these skills, if you want to be hired, you can get a stick that you're hired. So make sure to come to our booth, and welcome everyone. Thank you so much.
Thank you, Dr. Sharif. Well, our next speaker is Megan Rizdal, so I'm pleased to introduce her. Megan Rizdal is a product lead and data scientist at Kaggle, the world's largest global data science and machine learning community, where she focuses on helping the world learn from data using collaborative tools and open data sets. Prior to her current role, she worked in marketing and market research and has authored dozens of blog posts, including interviews with top data scientists from Airbnb and DeepMind. She has a master's degree in linguistics from the University of California, Los Angeles, and North Carolina State University. So let's welcome Megan Rizdal.
Hello, thank you. Very excited to be here today for my first Big Data Day LA. Great. So in my talk today, I'm going to share with you two of my favorite things that our team at Kaggle has learned about what data scientists need to successfully collaborate together on data projects. These two things have shaped how our community has grown to become the world's largest online community of data scientists over the past 8 years. So first, for those who aren't familiar with Kaggle, I want to give you a quick tour of our platform. Today, over 2 million data scientists come to the platform to do data science projects. They do this by participating in machine learning competitions and by publishing and exploring data that's shared on our datasets platform. For both competitions and for our datasets platform, users can analyze the data in R or Python and share their work with our hosted notebooks environment that's called Kaggle kernels. So all of these competitions and the submissions that our users have made, the open source code that they share with the world in kernels, and the public data sets have added up to insights into how data scientists work together to solve problems. And these are some of the insights that I want to share with you today. So the first lesson that I want to share is about the huge impact that access to socially validated knowledge has on data scientists' ability to successfully collaborate on data projects. So when we launched Kaggle over 8 years ago, we learned early on that the community is highly motivated to share knowledge, but sometimes discovering and building upon it was extremely difficult. So when each competition ends on Kaggle, our users share winning and innovative solutions. They share these insights on our forums. They've published over 200 How I Did It interviews on our blog. And often they even publish papers exploring novel approaches, for example, using WaveNet for sales forecasting, or some of the earliest work done on diagnosing diabetic retinopathy using recurrent neural networks. So now whenever a new competition launches, there's this tradition where users immediately go to scour our website and the internet at large to assemble these bits of knowledge that they can then use to kickstart their work on a new challenge. So to contrast this huge array of knowledge that has to be compiled from all over the web, I want to tell a story where centralizing this knowledge on Kaggle and adding a social feedback loop had a huge impact. And this is the story of the development of XGBoost, a gradient boosting library. In its early days, the author Tianqi Chen seeded discussion about his new package on forums, on our competition forums, and he gave users clear instructions for how to install this new package he was developing. Because he shared on the forums with users who were in the midst of working on solving problems, he was able to respond to feedback and reports of unexpected behavior and crashes. And even when each competition ended, he would solicit feedback via surveys to be able to use as input into developing XGBoost. Now, several years later, and XGBoost is one of the winningest algorithms for doing machine learning on structured data. And this is thanks in huge part to the close feedback loop with users in the community, where knowledge was able to accumulate and improve in quality. So I want to return then to the example of the flood of knowledge that's generated with each competition. Today, we provide more tools that enable users to discover related content on Kaggle to the problems that they're trying to solve. In an example of this, one of our users leveraged our public data set about Kaggle, aptly named MetaKaggle, to create a master list of all these winning solutions that were before spread across all kinds of forums. And he organized it by problem statement and characteristics using tags, for example, multi-class classification. So now whenever a competition launches on multi-class classifications, they can reference this list and see what work has done previously. In a similar example, this user used the same data set, and he used tags and other metrics of popularity and usage to create a data science glossary of all the top open source code that was shared in kernels that's organized by techniques. And this is, again, a really huge, exciting resource to our community. So then what's the lesson that we've learned from examples like this in our community? We at Kaggle strongly believe that no one beginning a data science project should begin from a blinking cursor. This is especially critical for new data scientists. Whether that means somebody who's completely new to the field and has never used random forest algorithm, or whether it's somebody who's new to a team and just beginning to explore a new space. It can even apply when new business or research questions are being asked. Using centrally located and searchable knowledge that's organized by relevance to the current problem at hand, data scientists should be able to start writing code faster and answer questions faster. We've also learned from these examples that knowledge that's been socially validated in our community, such as the XGBoost example where there was this close feedback loop, or through the availability of popularity metrics, is critical to identifying and then iterating and improving on good ideas. So then the second insight that I want to share with you that we've learned from our community about collaborative data science is the importance of making your work reproducible. And this is not just for those that you're collaborating with, but also your future self. So to illustrate this, I'm going to return to a competition from 5 years ago. And in this forum post, this user, with all of the best intentions, wants to get more people involved in solving the challenge at hand. However, in his forum post, we're observing many of the stumbling blocks that data scientists encountered at the time when they were trying to share their work. So first, he's sharing his code in a paste bin. We'd also very commonly see that users would attach R or Python code to their forums, and this requires other users who want to collaborate and contribute to download that code and figure out how to run it locally. It's the equivalent of passing code via email attachments. Second, he lists out his assumptions about the shape of the data. He has to do this because he's not sharing the data itself. Finally, and for me, this is the real kicker, he adds an update at the end of his post. Someone else, in a brave attempt to collaborate, has identified a bug in his code. So he's gone ahead and adjusted his code in the paste bin, which is of course the right thing to do, but it leaves anybody who previously downloaded that code in the dark. So all of these things, which we commonly saw in Kaggle's community forums in the early days, mean that code, ideas, and results were extremely difficult to reproduce. And this was a huge obstacle to collaboration, even when the will is clearly here. And for many of us in our day jobs, this is a necessity. So in response to this observation about our users attempting to collaboration and the problems that they were facing, we launched Kernels. This is our free hosted computational environment for notebooks and scripts. So to illustrate the impact of kernels, I'm showing here one of Francois Chollet's tutorial kernels that demonstrates how to use his then new library, Keras. And he shares all of the code to achieve a really respectable score on a competition predicting West Nile virus. This made a massive difference because kernels are versioned packages of code, data, and environment. This means that over 60 users, just for this example alone, were able to fork his code and make and execute from their own copy. And they could do so with a simple click of a button. So this is in huge contrast to the example before. It also made a huge difference in the trajectory of the popularity of Keras on Kaggle. So as recent as June, over 1,500 Python kernels import Keras on Kaggle. Finally, we know it's not just about the tools and the infrastructure. We've also observed, and we learned from talking to Kagglers through interviews, that they adopt some best practices that I also want to share for their data projects that tend to fall into two categories. First, templatization is a best practice for things like using a common directory structure across projects, modularizing your code and data, and especially when collaborating with a team, creating and sharing libraries of those commonly used code snippets from project to project. And then the other category is documentation. In addition to documenting code, our users document their data on Kaggle. And top Kagglers that we've interviewed also commonly report keeping close logs that include steps to reproduce the results of their work and this is especially the case if they don't use kernels. And finally, one smart thing that they do is they also use these lab-style notes to keep track of ideas that they experiment with, hypotheses that they test, and the results that they obtain. And this is while they're iterating through a data project. And this means that ideas and null results aren't relegated to a file drawer where they collect dust, but they can be learned from and built upon. So what's our lesson from these examples? More people will be able to interrogate, use, and extend good ideas in data science if those ideas are easy to reproduce. Reproducible data science projects package together versioned code, data, and environment. They also use best practices like templatization and documentation. So to conclude, we've learned that the two things that enable data scientists to be successful when they collaborate is access to socially validated knowledge and the ability to reproduce their and others' work. These insights and others, many others, have informed how we've developed our datasets and kernels products that allow our users today to collaborate on data projects beyond just competitions. So if you found any of this interesting and you'd like to discover and share more insights about how data scientists collaborate, I encourage you to check out the MetaKaggle dataset that I mentioned that contains all of our public data about Kaggle and Kaggle users. There's a lot of kernels that you can fork to get your project started. Thank you.
Thank you, Megan. I have a little certificate for presenting. Thank you.
Thank you.
Thank you for coming today. Hello. All right, just testing this. Thank you, Megan. Our next speaker is Ken Wiener, CTO at GumGum, a silver sponsor of Big Data Day LA. Ken leads the engineering product teams behind the industry's top computer vision platform for marketers and rights holders. As an active member of the ad tech community, Ken is a guest columnist of VentureBeat and Forbes, a frequent speaker at conferences, and a member of industry groups such as IAB's OpenRTV Working Group and various LA ad tech meetups. Wiener was LA Business Journal's 2015 CTO of the Year, and in 2003, he was included in the InfoWord 100 of his work at uPortal, an open source web portal framework for the higher education community. So let's welcome Ken Wiener. Hi. Thank you.
Hi, everybody. First, I just wanted to thank Subhash for creating this conference and for the team for inviting me here. Today, I'm going to talk to you about visual data. Where's the clicker? Here we go. There we go. Before I get into my talk, though, I just wanted to introduce the company I'm at, which is GumGum. So GumGum has been around for about 10 years. We're headquartered in Santa Monica, locally. We have grown to about 280 people across the globe in about 16 offices. We've been growing tremendously, and we work with a lot of the brands you would all recognize, the Fortune 100 companies out there. So as I get into visual data, there we go. It's important to understand why even be concerned with visual data. So for one thing, images and video are everywhere nowadays, except on the screen right now. You can find it on all the websites you visit, all the editorial and news sites, out in the social media, increasingly with virtual reality and augmented reality, and of course on TV and set-top boxes and everything that's coming out today. And particularly within social, you might have noticed that a lot of the top social networks are now just predominantly all imagery and visual data. You've got people like Pinterest and Snapchat and Instagram, where really all you're doing is looking at images. In addition to that, you might not be the only ones taking photos with phones. You're going to start seeing images and videos captured everywhere. You know, the Internet of Things is blossoming, and all of those things are increasingly getting cameras. In fact, Evan Nisselson, who runs a VC firm in New York that focuses on companies who do visual data and computer vision. He said at his last summit, the Internet of Eyes is the next big opportunity after the Internet of Things. You'll see cameras in autonomous vehicles. It may even be in your refrigerator. You're starting to see them in the mirror in the bathroom. It's getting kind of crazy. I wanted to break down what visual data might mean to an engineer. So, how does one encode an image? Well, in this example of this image of a dog here, it's 360 pixels by 480 pixels. And for each pixel, you can get an RGB value. So there's a red, green, and blue component to that pixel that can be represented by a number, let's say between 0 and 255. So if you multiply that all out, you get a matrix of numbers that represents that image. Now that ends up being about 500,000 discrete values of numbers. And if you put that in a file, save it on disk, that's about 2.5 megs of data. So you can see visual data is actually big data. It can take up a lot of room. Now, especially if you consider video, because a video would be many, many frames of images. So you could multiply this out by how many frames of images are in a video. Now, how do you represent, let's say, objects within an image? Well, usually you would have somebody annotate the image by drawing a bounding box around the object of interest, in this case, a dog. And then you could put coordinates on the center of that bounding box, and also the width and height of the bounding box, and you could end up with a vector of numbers that represents that object within the image. So what can you do if you have a bunch of visual data? You've got a bunch of imagery, and you've got a bunch of annotated objects in an image. You can do things like deep learning, which is a type of machine learning where you can train the computer to understand what it's seeing inside imagery. So I showed you a few minutes ago what a bounding box input vector might look like. If you get a lot of those and you feed them into a deep neural network, or more specifically a convolutional neural network, which is common for images, you can get the computer to then see a new image and understand what is it finding in that image and actually where is it located. So it can actually precisely find that object in the image. So if you want to do deep learning, though, you need to train your machine with a lot of examples, sometimes hundreds of thousands of annotated images. So where can you get those? I kind of broke it down into 5 or so different categories of sources of data. So for example, you might be a company that just has proprietary annotated data, like Google has Google Photos and people are tagging them and uploading them. So they have a big treasure chest of annotated data. Or you could look in the open source community. There's plenty of data sets that people have put together in the academic environment and otherwise, and you can grab labeled data from there. You may, if you don't have that data that you need anywhere, you could try to crowdsource it by using platforms like Mechanical Turk and other companies that have sprung up that will help you show data to thousands of annotators that will give you the labeled data. And then finally, you may want to build that kind of capability in-house if this is your business, like it is for us. You may want to build tools that allow people to annotate specialized types of images. And lastly, you might be able to generate or synthesize the data. So if you want to make more of the data, it's a common practice to take an image that you already have and try to tweak it or distort it in various ways to come up with additional training data. That's called data augmentation. Or you may take something of interest and just simply superimpose it over a lot of different types of background images. And people have success increasing their training sets doing that. So what can we do with visual data? Well, this is something we think about a lot at GumGum. In fact, GumGum doesn't actually sell computer vision as an API. What we do is we call ourselves an applied computer vision company. So we tend to develop a business around the capability of doing computer vision. And we've developed a few different businesses so far, the biggest being advertising, where we can do contextual analysis of web pages and images and videos and be able to target ads according to the context of what people are looking at. We have also applied this to a sports valuation business where you can understand the where logos are appearing in sports games to help quantify the value that the sports teams are giving their sponsors, and also for social analysis if people want to know what's happening with their brand in social media. Here's an example of in-image advertising where we have detected on a page that there's some people with eyes facing forward and we want to advertise a campaign about witches. And what we did was we have turned the eyes green for a few moments while you're looking at the photo, and then it kind of settles down into an advertisement. This is one of the first examples, I think, that you may have seen out there of where content and the ad creative are actually kind of dependent on each other. They don't exist separately. And I've got one more example of that, where Toyota was doing a campaign around the holidays, and they put they looked for people's heads to put a Santa hat on. And again, it collapses down into an ad. And I mentioned with sports, we're analyzing broadcast television and social media. And we basically are looking for all the different brand logos that appear, like on the court, on the basket, on somebody's jersey. There's a different value that can be attached to all those things based on where it appears, how long is it on the screen, how blurry is it, how much is it occluded, and that kind of thing. And we can basically sum that all up in an actual monetary number that helps the teams understand what they're providing to the sponsors in terms of monetary value. With our social product, as I mentioned, we're ingesting the photos from Twitter and Instagram and Facebook and anything that's public. And we call it social listening or social watching in a way, where you are looking for objects or logos of interest, and then you can then tell the sponsor or the brands, how are people interacting with their brand out there in the social sphere. And this is the newest thing that we've been working on, which is in the medical space, specifically in dental. And we're helping dentists basically look for and detect pathologies that are in dental x-rays. And what this is for is kind of helping them not miss anything, but also, sometimes patients don't really trust their dentists. And we want to give them a sort of unbiased third-party computer prediction of what's showing up in their x-rays so it can agree with what the dentist might be telling them, and also give them the ability to track that over time and show patients how things evolve within their x-rays. So I just want to end on letting you know that GumGum is hiring, and we'd love to have people that are interested come out and talk to us at our booth today. We've got a lot of positions for computer scientists, computer vision scientists, and natural language processing jobs, and all kinds of big data engineering jobs. So come out and talk to us, and thank you for listening.
Again, thanks, Ken. I'm pleased to introduce our next speaker, Mike Limcaco, advisor, principal architect at Agilysym Consulting, a platinum sponsor of Big Data Day LA. Mike is a senior technology advisor of his team, passionate about advanced analytics, including streaming analytics, ML, and AI, and brings over 25 years of large-scale systems design, development, and operations. Mike previously was the technology leader of the AWS Solutions architecture team here in Los Angeles, and worked as a management consultant at various firms, including Ernst & Young, Deloitte Consulting. Mike has been a featured speaker at Amazon, Gartner, and UCLA Anderson School of Management events. So let's welcome Mike Limcaco.
Good morning. Thank you all for coming out here. I know that ended with a bad phrase there, UCLA. I'm here at USC, so I apologize for that. But really just a quick 2 minutes of observations from the field. Many of you are working or starting to work in this industry, and I want to give you a few observations from the customer side of things. We get a lot of opportunity to work with a number of customers, and it's really an amazing time to be a part of this industry. Let's see if I can learn how to use this. There you go. So again, my name is Mike. Long time working in this field, have had the pleasure of working a number of roles to be able to support customers building data solutions. I can tell you quite honestly, now is a great time to be a data nerd. There are so many fantastic scenarios, tools, and techniques that we're all working collectively and making a big, big difference in our customer spaces. Whether it's, for example, working with a client to ensure that they can simplify access to a 25 petabyte data lake using a conversational interface. Whether you're working from high orbit, trying to help farmers improve yield and predict yield based on land use, taking spectral data band, combining it with weather, soil, environmental, and trying to build a classification model to be able to predict where they should be planting the next crop. And if you're a gamer or have children who are gamers, or you're a recovering gamer, I'm sure many of you have heard about Fortnite and this massive event that happened in July. 125 million players, can't be wrong, 37 terabytes per second. Amazing use case. When you're dealing with this kind of scale, as we all are, we have to think about the mindset, the technical approach that we have to be able to leverage for these unique use cases. Big data today, I understand we're going to be coming up with a new phrase maybe on how to address this community. I propose enormous data, because that's where we are. And if you do a quick scrub of the sessions, build up a word cloud and do stemming and then surface and aggregate the data to the top, this is what you get. Lots of big data today in today's sessions, but of course, other cool things like AI and machine learning, streaming analytics. It's going to be a great day for you all to get excited to see the new sessions that are coming up. And I invite you to come by, say hello. We're hiring. We build cool things. Thank you for your time.
Thank you, Mike. I got a certificate for you. Oh.
Thank you. There you go. Graduated.
Thank you, Mike. Our next speaker is Gwen Shapira. Gwen is a principal data architect at Confluent, helping customers achieve success with their Apache Kafka implementation. She has 15 years of experience working with code and customers to build scalable data architectures, integrating microservices, relational and big data technologies. She currently specializes in building real-time, reliable data processing pipelines using Apache Kafka. Gwen is an author of Kafka, The Definitive Guide, Hadoop Application Architectures, and a frequent presenter at industry conferences. Gwen is also a committer on the Apache Kafka and Apache Scoop projects. So let's welcome Gwen.
Thank you, everyone, for spending your Saturday morning with me. This is super exciting. If you ask someone from the 1960s to imagine the future, you'll end up with flying cars and robots and absolutely no Wikipedia. Because you take what you see right now in your life and try to extrapolate how it will get better in the future. And this is going to be the Jetsons keynote. I'm going to take the big trends that I'm seeing in the industry right now and try to imagine how they will look maybe 5 years into the future and what it means for data architectures. So I'm going to start by 3 ways the world is currently changing. The biggest one is cloud, and cloud changes everything. So it changes actually 3 different things in our world. First of all, we have to learn as data engineers to live with APIs. The data is no longer just in my database. If I don't know how to get all the data from something like Salesforce, my ETL pipelines and my reports are going to be missing lots of data. Second, we are going to have data on-prem, in this cloud, in that other cloud, all over the place. So you have to build data pipelines that can really span multiple locations, multiple data centers, bring it all together. And third, cloud is a very volatile environment. You have to live in a world where the services you're running, a machine can just go poof and disappear. And this is something that you have to build very resilient architectures to deal with. On the other hand, it's also very flexible. You can just flick your fingers and get more resources when you need them. So you want to build architectures that are flexible and can take advantage of the resources. This is what we call cloud-native data pipelines, and it's going to be a huge part of our future. Second thing that is changing is microservices. Microservices basically mean we take a big application and break it down into small chunks. Each are its own unique context of execution. They often have their own data. They often have their own database. So suddenly, you don't have to deal with 5 databases. You have to deal with 30,000 databases. Each one of them is very unique. And your CFO still needs this quarterly sales projection first thing on his desk in the morning, no matter that the data now comes from 30,000 different databases. So you have to build something that knows how to interface with all those microservices. But there is also an opportunity there. You can use the insights in microservices to structure your data pipelines from those small independent units, making it more resilient and more flexible to live in the cloud. So silver lining, I guess. The third thing that is changing is DevOps. And by that, I really mean that developers are doing everything right now, which means that they're also doing ETL, and sometimes they don't even know that they're doing ETLs. They tell me, I'm building a fraud detection app, and they ask, what does it do? And they say, well, the data comes from MySQL database. I use this extra special algorithm to find things that look suspicious, and I send it all to Elasticsearch so someone can take a look at it later. And I'm like, oh, fantastic, that's great ETL. He doesn't know he's writing ETL. That's his fraud detection app. Well, since he's writing a fraud detection app, he's going to use his favorite programming language, not a point-and-click tool. He's going to want to integrate with GitHub. He wants to use his CI/CD. He wants to write unit tests, all the things that developers normally do. Well, we need to make sure our data pipelines can integrate this kind of new mode of development where developers are doing everything. So, see, knowing that 5 years into the future, we only have more clouds, more special Snowflake databases, and more developers doing stuff that may or may not be ETL, what are we actually going to do? I'm going to ask you to try to imagine your data as a stream of events. This is the insight of this presentation. Everything that you have, people walking in and out of stores and buying things, clicks on your websites, searches on your websites, microservices talking to each other, inserts, updates, and deletes in a database. This is all streams of events. That's right, your database is a stream of events. Relational model, the indexes, everything you think is a table, it's an illusion. If you look beneath it, the source of truth of every database in the world is a transaction log, which is a stream of events. So if we look below the illusion and tap into the stream of inserts, updates, and deletes on every database, what is known as change data capture, we can build better ETL. And this is really what is at the core of Apache Kafka. The idea that you can see everything in a stream of event, capture all those streams at large scale, bring them together, integrate them, look at APIs, microservices, clouds, databases, they're all the same, and therefore you can integrate them, join them, aggregate them, send the data everywhere you want. It's all just producers and consumers of streams of events. That means that we can do everything to every source of data in our organization. What does it look like in practice? Well, imagine that you're a data architect. You may be, I am, and someone from the marketing department wants to do a new promotion. Send some email to special type of people who do special things. How do we do it? Well, we start with the clickstream. Who is actually looking at those properties? We consume the clickstream into our application. We enrich it. We take user ID and we check if it's a platinum user. We make a decision, promote or not promote, and produce the result to a promotion queue. Sounds very simple. I thought it's simple. I thought I'm freaking done, except the devil is always in the detail. So in order to know that the user ID is platinum or not, I have to ping the database. Pinging the database is not a problem. Kafka can do millions of events per second. My DBA did not appreciate millions of queries per second worth of workload showing up one nice Friday evening. And he had my home phone number. Not a good idea, I needed plan B. Plan B for every data engineer with a DBA yelling at them at Friday night is going to be using a cache. That's nice, the DBA is now happy, but I have one of the biggest problems ever. How often do I refresh this cache? Refresh it too often, and the DBA is now yelling at me again. Refresh it too infrequently, and the marketing people are very unhappy about me using stale data for their promotion. If only I had a way of knowing when things happened in the database. If only I had a stream of insert updates and deletes that are going on in real time. Turns out that I can have it. That's exactly what I do. I do change data capture. I get all those insert updates and deletes out of my favorite tables in the database, consume them into my application, join them with the click streams that I already have, use it to populate an internal cache, and now I have a private copy of the data in my own little microservice, just like everyone else, and I can use it to make decisions with our own real-time data that is always up to date without ever bothering the DBA. Now you may say, well, you know, that sounds complicated. All I know is really some SQL. It is not complicated. That's the whole point. All you need to know is just some SQL. Apache Kafka shows up with Kafka Connect, and there is a lot of connectors. There's a lot of connectors that do change data capture. So you plug in a jar with your favorite change data capture connector, and you get an extra stream of events. Now you use KSQL, the SQL stream processing language that works with Apache Kafka. You do a join. You actually need to do 2 joins because there's hotels and the users, and you produce the results to a new stream of events. This is actually easier than writing most applications. This is maybe the easiest ETL job that you've ever written in your life. So here we are. We not only managed to get new sources of data and do things in real time, we made our life easier. Isn't it like perfect? So I hope you got good insights out of this whole discussion about the future and about what you can go and build to build an ETL platform that will really survive like 5 years into the future. I hope you'll get a lot more of those insights today. I hope you'll all have an amazing day because it's just gorgeous here in LA and I'm super happy to be here. Thank you.
So I'm pleased to introduce our next speaker, Justin Hertz, Executive Vice President, Digital Product Platform and Strategy at Warner Brothers Entertainment, a silver sponsor of Big Data Day LA. As head of Warner Brothers Digital, Justin oversees emerging technologies, new platforms, and direct-to-consumer technology working across all divisions of the studio, identifying and spearheading technology-related innovations, intersecting with new digital products, production, distribution, and marketing. Warner Brothers Digital portfolio includes digital innovation, technology development, standard setting for the studio, direct-to-consumer platforms, and Warner's consumer intelligence data activities designed to generate value by creating and enhancing consumer engagement through direct interaction with Warner Brothers products, programs, and partners. So let's welcome Justin Hertz.
Hey, thank you. Put my stuff here. All right. Thank you. What's that? All right. I've heard the clicker has been problematic, but hopefully it'll work for me. Thanks a lot for having me here. And thank you all for attending. It's great to be here so early on a Saturday morning. Hey, I'm Justin Hertz from Warner Brothers, and you know, most likely Warner Brothers does mean something to many of you, you know, in the auditorium. But what you might not know is that we're really involved in every form of entertainment. across the industry, from film to television to games, consumer products, and even live events as well. And we're a leader globally in all of these businesses. In fact, we're particularly proud of the performance of our games publishing business. We're really the last studio to have a scaled games business. We generated over $1 billion in revenue last year. So this is really an important part of the studio business. We continue to diversify. So, you know, you might know us for the films we produce, or you might know us for Bugs Bunny or Hanna-Barbera, but we're doing lots and lots of content globally, including lots of digital content as well. We're a home for really brands and franchises that people love, you know, from Lego to Harry Potter. I really like the horror stuff we've been doing. It was a great movie. You guys should see it if you haven't. But these are the franchises that people grow up with and consume and interact with, you know, really through their entire lives. So despite this huge scale that we have from an entertainment perspective and from a reach in terms of the audience, because the business of entertainment has really been about producing entertainment, which is then taken and distributed by our distribution partners, our connection to the consumer has been historically very, very limited. We do panels for research, and we do test screenings for new movies and things like that. But the kind of like minute-by-minute interaction, understanding, and the kind of relationship that can develop with a consumer over time by seeing how their choices, their preferences change and evolve, we've really been sort of disintermediated from that point of contact. And so going back about 10 years ago, we decided that in order to compete going forward, we really needed to establish a connection with a consumer that was very, very different. And we did that by assembling a data asset and a tech stack that has grown to a really, really meaningful, significant size, where we have hundreds of millions of entertainment consumer profiles industry-wide. We have billions of interactions that tie back to those profiles that can be anything from buying a movie ticket to watching a trailer, playing a game. And we also have trillions of business records from across all of these global businesses. We've put these into a modern data environment that's allowing us to make all kinds of different connections that historically we really, really couldn't. I think in the intro, the Data Intelligence Organization was mentioned. That has been really a labor of love for me, as I said, for about a decade. But where it stands now, and I think we have a recruiting table outside, so you guys can talk to some of the team later, where that group functions now and the kinds of things that they are doing. Frankly, I couldn't even really imagine back when we first started to think about this as an opportunity. So this data set that we've connected is allowing us to make connections and do analysis across all different types of consumer touchpoints, all types of different businesses, looking at our content as it moves through the different industry release windows is a great example where, you know, a movie will come out in theatrical, then it might be available in home through one of our digital partners or through our physical partners. It might intersect with consumer products, and it might even end up in theme parks. Being able to look at how consumers are interacting with that content through all these different channels and think about how we can make better experiences, more relevant advertising. These are some of the sort of key types of activities that we engage in. most recently, I'd say over the last year, give or take, we've been bringing data science, applying it to these data sets that we've put together and creating value across the studio. And we just have a couple of examples of some of the things that we're doing. It's pretty diverse and pretty interesting. I talked about marketing. That's kind of an obvious one, right? We're modeling audiences that have a high probability to buy a ticket for a certain movie or may be interested in a certain game or TV show that we're producing. But we're using it in all different parts of the studio. So we're using AI in our visual mastering and color correction process to take some of what has historically been manual activity and create algorithms that can generate really good first passes on creative production techniques, then can be evolved, tweaked, and touched by hand after that. We're doing dynamic pricing optimization for certain parts of our business. We're doing machine learning forecasting for all kinds of areas, but we're also intersecting with new emerging places where we think entertainment could be really valuable. And one I'd like to point to is our autonomous vehicle research and development activity. So we're invested in and partnering and developing what we believe will be sort of the next forms of entertainment as consumers stop putting their hands on the wheels and paying attention to the cars in front and back and on the sides, and lean back and commute in a whole new fashion. And the data sets that are generated both in car and through all these interactions across all of our touch points are helping to inform new ways of creating entertainment or presenting entertainment in what is an emerging new environment that even 3-4 years ago we weren't thinking about at all. So these are some of the ways that we're bringing data science across the business. But one thing that is really sort of interesting and I think intriguing and challenging is that creating value out of data science at a company like Warner Brothers really acquires human adoption. It's different than plugging it into an application or a product, which is challenging in itself, but you need to build connections with people in order to get these techniques adopted. And some of the measures of validity, like prediction accuracy, that people in this room might look at to say, oh, well, this is a technique that can bring a lot of value to whatever use case I'm looking at, is often not enough to create traction within a company that is nearly 100 years old on the theatrical side or 70 years old on the TV side. I like our dragging the horse to water image over there. We spend time thinking about how can we create adoption and what can we do to bring these techniques and create value across the studio. I've highlighted a few of them up here. Inertia, the fact that these businesses have worked in a certain way for such a long time creates some resistance to new techniques. Data science outputs look somewhat similar to outputs that traditional panel-based measurement tools can give, but the large data sets that sit underneath what we're doing are obviously very, very different and can produce very, very different results. One of the areas that has been getting a lot of press, and hopefully you guys have seen some of it, is that what's really confounding is that some of the most accurate data science techniques are often the least explainable. So as you start to leverage vector machines and neural nets to do some of the analysis and prediction and modeling that we are doing across the studio, it can be almost impossible to explain why that outcome is the outcome, and that creates a tension between adoption. So at certain points in time, I like to say that it almost feels like it requires a religious conversion to adopt these kinds of new techniques. And you've got non-believers, you've got people who sort of jump in with both feet very, very quickly. But most people need gradual conversion over time. And some of the things that we focused on to ease that adoption are data visualization, telling a story through the images and interfaces that contain the data, putting a human explanation around it, having actionability. You need to make sure that people can actually do something meaningful with their job based on the predictions and outcomes that you're forecasting, and also changing your organization. Putting data scientists and analysts in key parts of the studio have been some of the really, really critical and effective techniques that we've used. To sum it up, and I think I'm right at the end, there is no silver bullet for adoption, but there are some things, some techniques, and some other learnings that I would leave you with. You need to prioritize, make sure you are going for wins that are going to bring value to the company. You need to understand the divisions and the way those divisions work within the company, because they have been doing things in certain ways for a long time. You can't go in and just say, oh, well, stop doing that. You know, you've only been doing it for 30 years. I've got a new thing for you to do. You need to build trust. You need to do things in parallel, and you need to contextualize the value based on the way that they have done their jobs in the past. And if you do that, you can reinforce and actually create adoption, and we have. So that's the little story I wanted to tell you. Hopefully you got a little flavor of Warner Brothers, some of the assets that we bring to the table. We have a recruiting desk, as I've mentioned. We'd love you guys to join our community. And you can text or go to the web, or you can just walk outside and see us near that park. Thank you very much, and have a great day.
Thank you, Justin. Wait, gotta get you started. 1 second. Here you go, sir. Thank you, Justin. All right, our next speaker is Tim Usterman, Senior Director, Solutions Marketing, Digital Business Automation, Business Unit at BMC Software, a platinum sponsor of Big Data Day LA. Tim leads the development and execution of market strategy, positioning, messaging, demand and content marketing, and sales enablement. His career spans over 25 years of B2B high-tech marketing in the supply chain and enterprise mobile computing industries. Tim's prior experience includes senior marketing and sales leadership positions with Honeywell Scanning and Mobility, Intermec Corporation, Vocalect Inc., and Zebra Technologies Inc. Tim holds an MBA from the University of Oregon, Lundquist School of Business, and a BS in political science from Oregon State University. He is co-inventor and patent holder for the #1 selling bioptic scanner scale used as point-of-scale checkouts, another around the world. So let's welcome Tim Usterman.
Thank you very much. Hello, everybody. How you doing? Great day today? I can't wait to get outside, and I'm sure you can either, so I'm going to make this pretty quick. My name's Tim. I'm from BMC Software. Delighted to be with you here today. We have a fantastic program for you today, and I'll introduce that a little bit later. But first, let me tell you quickly about what we do at BMC. I represent the Digital Business Automation business unit, and we have a product called Control-M. And what we do is we help companies around the world, from 100-year-old manufacturers, the largest banks in the world, to born digital in the cloud native companies today. We help them integrate, automate, and orchestrate their business application workflows. We find ourselves at the intersection of diverse infrastructure challenges, the challenges with big data and the disparate nature of big data, how difficult that is. You all know all about that. And we help people accelerate their applications into production with our Control-M product. So one of the companies that we work with is a company by the name of Malwarebytes. Does anybody know Malwarebytes? Do you use it on your computers? So Malwarebytes is a malware threat detection and remediation company. They're up in San Jose. These are the guys that were like born in the cloud. These are full-on digital natives, and they've built their business on the back of big data. And what I have seen them do in their headquarters is they have a geospatial mapping capability where they're live streaming data from trillions of points out in the market and tens of millions of their endpoints, and they're actually mapping the propagation of malware as it goes from city to city, country to country, and their data engineers and analytics people are able to look at the threats and remediate those threats on that day. That's called zero-day remediation. The good news for you all is they're here today. They're going to come and present, Sujay and Sathwik are going to come and present at 11:20 in the data track, and they're going to talk to you about how they have built in the cloud, in multiple clouds, this platform that drives their entire business. They use Control-M as kind of the spine underneath which they align all of their big data ecosystem and architecture. So I really encourage you, if you want to see a real-world application from guys that are absolutely on the cutting edge of what we're all about here today, come and see Sujay and Sathwik in that track. And last but not least, we're outside. Right as you exit the building here, we're straight out, right on the left. And apparently the marketing team, unbeknownst to me, decided they wanted to give away a drone today. So if you're interested in drones, you can come out, see us. Sujay and Sathwik will be with us, and they'll answer any of your questions. We also have some technical folks there as well. So delighted again to be here. Thank you very much, and we'll see you later today.
Thank you, Tim. I got the certificate for you. For you? Yeah, appreciate it. Thank you. Thank you. Thanks again, Tim. I'm pleased to introduce our next speaker, Diego Sainz, Managing Director at Accenture, a global sponsor of Big Data Day LA. With responsibility for Accenture Digital and AI delivery for the Western United States, Diego's focus is on applied intelligence, digital transformation, and customer experience design for Accenture clients in the communications, media and technology industries, including Facebook and Twitter. A technology entrepreneur with prior experience in consumer products, retail, travel, and automotive, Diego previously served as CIO for Pepsi Latin America. So let's welcome Diego Sainz.
Hello, sir. Where's the mic? Thank you. Good morning, everyone. I'm delighted to be here. It is my first time at the USC campus, and it is an awesome campus. I am just a Miami boy. I spent a lot of time on the East Coast, and I got a call from my boss one day that said, "Hey, Diego, we need your help." I said, "What's going on?" He says, "We need to develop this very large analytics platform for a client on the West Coast." And it's a big social media company, and it starts with F, right? So it's Facebook. And we came in there, and it's incredible. I remember doing systems. I was at American Girl. We were doing Black Friday shopping cart transactions. We had to do like 50,000 checkouts per second, and we thought that was big, right? And it is big. But when we look at the Facebook scale, you get to understand what really AI at scale looks like. And it's a lot more difficult than it looks like. It's really deceptive when you look at AI and the fact that you can spin up a Jupyter notebook, you can spin up an RStudio, you can spin up a cloud instance, and you can run machine learning models and get it up and running very quickly. Kind of my own mental model is, it's like golf. I grew up in Miami, going around all these beautiful golf courses, and when I was a kid in high school, I'm like, that looks easy. It's like a little stick and a white ball, and you just hit it. Until I actually went to a golf course and said it's extremely difficult to play golf. So that's why today I want to share with you a bit about AI architectures. To do AI at scale, it is very, very important that you have the right AI architecture. And this is a fundamental change. It is a fundamental change. We have clients that come and say, I have this architectural design, do your magic and make it smart. Build me a smart application, right? So I'm going to share with you 3 things today. One is a couple examples, kind of reference points in terms of best-in-class architectures that handle very large numbers. You've heard all morning things like trillions and billions, you know, in streams, and it is true, but it's very difficult to get all this together into an end application. So I'll give some best-in-class examples. I'll talk about what are some of the principles that we need to keep in mind as we design this. Otherwise, when you get your very large data and you're trying to do machine learning, when you're trying to build deep learning, you know, it's going to be very, very challenging. And also, I want to make it personal in terms of what it means for you. So so now, after my role now is I am in the West Coast, run the portfolio for the West for digital delivery. Uber is one of our clients. And without divulging any confidential information, I think it's obvious that data is heart to their business. Their business runs on data, right? Whether it be passengers, pickups, locations, times, predictive, right? When you look at that, a lot of our clients will come to Uber and say, we want to be like Uber, right? Another one that's very interesting to me is Qulu, which is a social media sentiment analysis to do predictive buyer preferences around social media sentiment. So they correlate a number of signals that is in non-structured data, about 750 billion cultural signals, to be able to do predictive based on unstructured data. So these are 2 examples of 2 smart applications. So we come here, and recently we had a client that come in and said, here's my stack, tell me how it'll work. You see that little yellow box there? Well, that's where you do all your smart stuff. And as we started to really look at it, and I got a team of 3 architects to spend all day with me looking at this, and we said, it will never work, right? AI cannot be a bolt-on application that you just add to a tech stack. It just will not work. There's a number of reasons for that. Quite frankly, I understand there's some legacy architectures, but as you build your new applications, you need to flip it. You need to put AI at the center. You need to put data at the center to have it make sense. And that has a big fundamental shift on everything, right? I'll give you an example. Most of you have probably done agile development. So in agile development, you are doing user stories and you're doing sprints. Well, if you're putting data at the center, maybe you need to shift that and start to think about data stories. What are the exploratory data analysis that we need to do early on in the agile process to be able to do feature engineering to make sure that we have the product functionality, right? So it's very important, as it's just that little simple flip is extremely, the impact of that is far reaching, right? So from Agile, how do you do that? From a DevOps point of view, how do you build in the cloud a platform that is able to run very smoothly from your data all the way down to your models, from your R&D exploratory to large-scale production? At Facebook, at F8 this year, they talked about PyTorch 1.0, which integrated both their R&D portion and the production portion into one product. For that very reason, it's very easy to experiment, very hard to launch at scale. So that's a very fundamental thing. Here's the 5 principles that you should consider when you're building AI-centric applications, which I think it's the next generation of any application. So the first one is AI will drive the user experience, right? We can no longer start with an assumption that it's going to be a web-based browser, click here, right? There are all kinds of inputs, with voice being an obvious one, right? How do you interact with voice? Maybe you don't need to click and select certain things if machine learning will be able to do that for you. So think AI as driving user experience. It is not another option on the stack. If somebody comes to you and says, we're bolting on AI onto this, do your magic, it's time for a hard conversation to say the magic will not work unless we do it slightly differently. This is important for data scientists, right? It's great to be a data scientist today. You get a seat at the table. We had never had more interest from CEOs in terms of wanting to be involved in AI conversations and how that impacts the business. So data science needs to have a seat at the table with the product manager, right, in terms of product decisions. Again, how do you access data through APIs, through microservices is hugely important. And then to make sure that DevOps supports that. So those are 5 guiding principles for you to think about. AI drives user interface, data science is at the table, make sure that you have a clear access to the data, and make sure your whole cloud platform can support it. So this is what the makeover looked like after we got done with this particular client, right? And I won't go into all the details here, but you can see how data starts in terms of looking at what are data assets. Data ingestion at scale is very, very difficult, especially when you have streaming data, when you have unstructured data, structured data, and then you build your data processing and then your model. Managing a lot of models at scale in an architecture is extremely difficult. And if the models break, your output breaks. So there's a certain level of rigor that needs to be had to make sure that that happens. And if you notice, the Salesforce app on the top right corner is no longer at the center, right? They were saying, we have Salesforce, start here. We said, no, we're gonna start with data, modeling, machine learning, and that will go into Salesforce. So you see the pivot I was talking about, right? It really is fundamental that we start thinking that way. So what are some of the competitive benefits? We are able, through this process of pivoting from a bolt-on to data-centric approach to deliver much, much more quickly. We introduce into Agile data stories versus user stories. We have exploratory data science as part of our discovery process. We are pairing data scientists with product managers to have better product decisions. So that is really a huge competitive advantage. You will go through a lot more trial and error if you don't have a seat at the table. So that's good news for all of us here. In terms of the technical benefits, it eliminates silos because you start with the data and you're breaking down those walls. So there's huge benefits both from the business and from a technology point of view. So in terms of what it means for you, well, lots of opportunity. That's what it means for you. It's a great place. I grew up in Miami, like I said earlier, and I was so excited when Accenture asked me to come to the West Coast because there is no better place to be than 2018 in the West Coast working on artificial intelligence and data science. So we're in a privileged position. The opportunity is limitless. I think that we need to get ahead of the curve. Most of the good books on AI architecture have not been written yet. There's one coming up from O'Reilly on October, there's one in September. There's some very good reference book, but this is an evolving field, and for those of you that are interested in that, maybe you can contribute to that community of thought. So again, AI-centric is the way to architect large-scale applications, and as a community, we need to change the way people think about it. Thank you very much.
We have a certificate for you. 1 second. Here you go, sir. And a shot. Thank you. Thank you, Diego. All right. Our last speaker, but not the least, I'm pleased to introduce Sari Ladin-Cian, Chief Data Officer at City of Los Angeles. Sari executes Mayor Garcetti's vision for a more responsive and data-driven Los Angeles. As a Chief Data Officer, Sari improves access to meaningful information for residents and city employees. She leverages her policy, knowledge, and technical skill set to form new partnerships that tap into the value of data as a critical asset in smarter decision-making. She previously worked as a Harvard Ash Fellow for the mayor's data team, where she led the team's digital strategy and elevated the city's best practices to the national conversation through her articles for Harvard's Data, Smart Cities, and Government Technology. Sari holds a master's degree in public policy from the University of California, Berkeley. So let's welcome Sari Ladin-Cian.
Hi, everybody. Thanks for hanging tight. It's great to be here today. Thank you so much to the organizers of Big Data LA for having me. What an amazing data-filled event. So as our MC mentioned, my name is Sari Ladine Cien. I'm the Chief Data Officer for the City of Los Angeles. You might be asking yourself, what is a Chief Data Officer? What is a Chief Data Officer in a city? Well, Mayor Garcetti appointed a data officer to streamline data in the City of Los Angeles so that we are improving operations, using data in a smart way to make our operations more efficient and deliver better services, and also improve civic engagement. And I'll be focusing my talk on sharing Mayor Garcetti's data strategy and also letting you know how you can get involved with all of your fantastic data skills to help make Los Angeles the most livable city in the world. So when Mayor Garcetti first took office in July 2013, data was top of mind. In December, he passed his third executive directive on open data. And that executive directive mandated that all of our departments unlock city data from all corners of local government and make it available in one central platform that has API endpoints and is accessible for any machine-readable project. The goal of that was also to make sure that data is becoming more embedded in the culture of government. And what I mean by that is that we're now using data to make better decisions. We're using data to move away from anecdotes, and we're bringing together our research community, our civic tech community, and other partners to really work together collectively and problem solve how we can solve some of the hardest challenges here in Los Angeles. So why is data so powerful in cities? Well, making raw data available on intuitive platforms help us engage with citizens and residents in more passive ways. So you don't have to attend a town hall meeting. You don't have to show up at your council office. You can now engage with us online through digital tools and use data yourselves to make community action happen. So if you're considering why there's no trash can on your block, well, you can go to our data portals and look at where all the trash cans are in the city. You can also use 311, which is our service request portal, to take a look at where there's trash in the city and make the case for why you need that other trash can. And that is a real story that a neighborhood council has done. We're also using data to promote innovation among entrepreneurs and businesses. There's no better success story for us than seeing a business thrive using our data. We make it available to you as you do pay for it with your taxpayer dollars. It's your data, so we want you to use it. We have amazing stories of businesses that got started here in LA and are now expanding all over the country, leveraging open data. One of those businesses started as a real estate intelligence platform. And so they're combing together zoning data and permitting data to help developers make smarter decisions in their real estate investments. They started here in Los Angeles and have now expanded to San Francisco and other cities, leveraging open data to do so. We also have different applications that have come about. So if you are concerned about getting parking tickets for street sweeping and leaving your car on the street during street sweeping, there are ways for you to use an application to actually be notified before you get that ticket. So we really encourage people to use our data for entrepreneurship. Data is also our biggest government asset. It's the most overlooked asset is city information. We have over 1,000 data sets available to you for you to explore. We also include county and federal data, so we're not just harvesting our own city data, but we're federating and connecting to other systems. So there's a whole world out there. And lastly, as I mentioned before, data brings everyone to the table. It's revolutionizing the way we govern and just breaks down the barriers that exist between the ivory tower and City Hall and makes it seamless for researchers to engage and provide policy expertise and data science to make our decisions better and to have more evidence-based solutions in government. So I'd like to tell you a little bit about how we're doing that for our departments. Just to give you a preview, Los Angeles is a city of 4 million residents. We have 40 different departments that deliver services to all the residents in Los Angeles. And we have over 60,000 city employees. So definitely a big task, and data plays a very important role in helping us deliver services in the most efficient and equitable way. So we like to think about smart decision-making with data in 3 ways. First, intelligent operations, tracking your problem. You have an issue with crime in a particular neighborhood. You want to look at crime over the entire city. We have a CompStat program, which uses a government stat model to essentially make quick, rapid response decisions, feeding in real-time data about what's happening in the community. This lets us be nimble and active and responsive in a way that we couldn't before the accessibility of data and machine learning that really helps bring this work together. And we are also working on tackling that problem and then analyzing it and thinking proactively about how we can avoid these problems in the future. Or how do we deliver services to the highest need neighborhoods that maybe are disenfranchised with government? Maybe they're not reaching out to us through council. How do we get services to them even without them voicing their concern? And so what we're doing is we're weaving together demographic data, data on digital literacy and poverty, a variety of different data for you to connect all of our resources into one place and deliver services more quickly. And lastly, the most important thing is sharing data. So we encourage our departments to use and leverage open data like social media to share out their story of what they're doing. So as I mentioned, we have 2 data portals. We have one that's data.lacity.org. That's our tabular portal that we launched in 2014 with over 500 data sets. We then have the GeoHub, which is our new geospatial portal. It's geohub.lacity.org. And both of these portals work together to share with you both spatial and tabular data so you can create story maps and applications and dashboards for your own personal use or business use. And then most importantly, data for data's sake is not very useful. We have a wide variety of constituents. Some of them are data literate, some of them don't know what data is or haven't really looked at raw data before. And so we have a variety of applications that we've developed. I'd be happy to share the links with you afterwards, and I'll just name one for the sake of time. We have this really nifty citywide web analytics site that aggregates all of our Google Analytics for all city websites on one place. So if you're interested in who's interacting with which department the most, or which site is the most, is the hottest site in the city, this is where you want to go. And what's really cool about this is that the library, without fail, is always the #1 site that people visit, and we're really happy about that. You can find lynda.com on the library, Audible books, all kinds of things. So we're really excited to see where people are engaging with us online. And I just wanted to mention, as I said before, we're really focused on engaging with all of you and really bringing data to the people. And so our goal is to not only work with people that are already digitally inclined or have a sense of what open data is. We really want to make sure that we're bringing everyone in on data. And so we've designed a data literacy training where we go out into the community and train people that are likely going to join a neighborhood council or are already civically minded on how to use data at a very basic level to really deliver community action in their neighborhood. And we've already hosted 8 of these trainings from Pacoima to Panorama City. We had one at USC, we had one in Boyle Heights, all over the city. And we're really looking to you to help us host more. So we have 2 opportunities for you today. You can help us host future trainings. Your companies can help us lend laptops or training sites for us to help us train more folks across the city of Los Angeles. And we also want you to get involved in our Data Angels program. So we have a program that is a big volunteer base, and we're really excited to say that we have some data angels in this crowd. But these are people who are already data-minded, have data skills, you know some Python, you know some code, and you're interested in just lending a few hours once in a while to help clean up some city websites or that sort of thing. So please reach out to me if you're interested in learning more about the Data Angels program. We love to feature people who are part of this program on our blog and on city websites and show the awesome work that you're doing. So feel free to reach out to us at mayor.opendata@lacity.org. Thank you.
Thank you, Sari. And thank you, everybody, for being here today. It's an exciting day. Our next sessions, we're going to split into, we have 5 tracks, as you might know. So we're going to start those sessions at 10:30 sharp. So we have about like 20 minutes. When you go out, please split into 2 lines for registration. Get your badges. Sorry about this morning's delay, but please do get your badges before you go to the sessions. And if you get lost or you need some help, we have volunteers in yellow shirts. Please ask questions. All right, thank you, everybody.